All right, so here is the problem. It's difficult to imagine what this looks like without a picture. So I'm going to go ahead and draw a picture. And you should think about doing that for every geometry problem in the future because it's really helpful if you can visualize and actually see what the problem's talking about. So we have a circular pond. Here is my pond, okay? And it's 12 meters in diameter. So the diameter of this pond is 12 meters. And it's surrounded by a brick walk that's 3 meters wide. So we're trying to find a brick walk that's 3 meters wide. So it has to be 3 meters here, and 3 meters here, and 3 meters here, and 3 meters here, etc., etc. So really we're just drawing another circle around this pond. So it's 3 meters wide. Okay, it says find the areas. Notice we're finding 2 areas here of the pond and the brick walk. Okay, so we are going to have to try to find the area of the pond and then the area of the walk. Okay, now we know that both of these are going to use the formula for the area of a circle, but we have to strategize a way to find the area of the walk, okay? I think that the area of the pond is going to be a little bit easier because we know that the diameter is 12, then the radius must be 6. So we know that if we want to find the area of the pond, I'm just going to use P for pond. We start out with a formula, pi r squared, and then multiply pi times the radius, which is 6, squared. So in our calculator, we would just multiply that. We multiply pi times 6 squared. And we get 113 1/10. So the area of the pond is equal to 113 1/10 meters squared. Well, that one was easy, but now we have to figure out the area of the walk. Okay, the walk is all that's surrounding that pond. Okay, well, which means we don't have a concise circle for that walkway. So that means we have to go about it in a different way. Okay, so I'm going to put this off to the side. We know what that is. Now, if we were looking at, this is similar to the last problem that we were working on. We essentially have a shaded region that's out here that we need to find the area of, right? But we don't need to find the area of this large circle. So we're going to use that method that we used last time where we take the area of a big circle and then subtract what we don't need from it. So, okay, well, if we know this is 3 inches here and we know that this is 6 inches here, then we know that this big distance has to be 9. So the distance from here to here has to be 9 since this is 3 and this is 6. So we can find the area of the big circle, right? And we already know what the area of the pond is. So in order to find the area of the walk, we take the area of the big circle and then subtract the area of the pond. We know what the area of the pond is. Now we have to find the area of the big circle, okay? So let's go ahead and start out with our formula. Since there's not enough space over here, I'm going to move over here. So the area of the big circle is equal to pi r squared, but we know that the area, that the radius length of the big circle is 9, so that's pi times 9 squared, and in our calculator, we'll multiply pi times 9 squared, and we get 254 5/10 meters squared. Okay, well now I can fill in the area of the big in order to find the area of the walk. So the area of the big is 254 5/10. And now we need to subtract 113 1/10 from that. Okay, one thing that's interesting about your calculator is here's what I was given. This is what I found for pi r squared, the last problem. If I want to, I can just subtract that 113 and 1/10 directly from it. So if I just press the subtracting sign, notice it says answer. That means that's the answer from the previous problem that you worked. So answer minus 113 and 1/10 is equal to 141 and 37 hundredths. I'm going to round to the nearest tenth though. 141 and 4/10. So the area of the walk is equal to 141 and 4/10 meters squared.